A pad can help make your pile more efficient and protect water resources. Without a pad to provide a solid footing, wet weather and spring melts can turn an otherwise attractive pile into an ugly, unmanageable mess. That same pad also can help prevent ponding by gently directing runoff away from water bodies. It can also save you from inadvertently mixing soil into the pile when you turn it. Look for a site with these quality characteristics. Find an upland site away from water bodies and built with a gentle slope of about 2% that drains away from water bodies. Avoid steep slopes and build windrows that run up and down the slope, not across, so runoff will flow naturally between your piles. To reduce odor concerns, consider both wind direction and who might be downwind. Keep your compost pile away from high water tables, which create these kinds of problems. They can flood the site, drowning and suffocating your hard-working microbes. They increase the potential for groundwater contamination and surface water contamination if the site floods. They make it tough for your equipment and vehicles to access the site. And use berms, compost socks, ditches, or drains to divert and direct runoff to safe places. Size will depend on both your volume and your process, which affects how long your compost piles will be around. Plan space for active windrows, curing piles, storing bulking materials, and equipment. Depending on your sales strategy, you may need room for screening, bagging, and loading areas for customers or distributors. When creating a pad, think carefully about managing water. As water filters through a pile, compost operations can produce leachate, which has the potential to contaminate surface and groundwater. You can reduce leachate production by laying down a bed of carbon-heavy bulking materials to absorb moisture, or you can install a berm to divert rainwater from entering the pile. For leachate that is generated, you have several management options. Collect it in a tank, control and filter it with a compost berm or sock, filter it with vegetation, or store it in a lagoon. Click on any of these options to learn more details. You can grade the pad to direct leachate into a tank and dispose liquid by adding it to the pile to increase moisture levels, applying it to crops, or hauling it to a sewage treatment plant. By mixing solids to suspend them in liquid, you can remove most solids when you extract the liquid. Expect some to remain in the tank, but don't let them build up. As they accumulate, they'll smell badly and may reduce the useful life of your tank. Those solids can be hauled away by a septic collection service. You can build a berm of finished compost to control runoff. The berm should be 24 inches tall by 24 inches wide and built perpendicular to the slope of the pile. Some composters prefer to create compost socks by filling cloth tubes with finished compost. Vegetation helps absorb nutrients and allows solids to settle before they reach surface waters. Consult NRCS standards for filter strips for compost pads. Retention ponds can provide capacity to hold water generated by normal operations and by storm events. Lagoons should be designed, built, and operated to protect water quality by addressing these key items. Is a discharge permit required? Removing and managing solids. They can be applied back into the compost pile, but if their moisture content is too high, they may need to be dried first. Preventing pollutant loading at discharge points. Consider a sand filter for that purpose. Managing seasonal water volumes. To ensure lagoons don't overflow from runoff or snowmelt, you may need to lower or empty lagoons before local weather produces peak flows. Liquids can be applied to field crops back into the compost pile as a moisture source or hauled away to a sewage treatment plant. Agriculture has developed 14 best management practices specifically for manure and farm waste management. They aim to achieve 6 basic goals for water quality protection. Reduce soil erosion and minimize sediment loads to surface waters. Limit discharges from livestock facilities to surface and groundwaters. Maximize nutrient use efficiency and minimize excessive nutrient loading into surface and groundwaters. Reduce contamination of surface and groundwaters from pesticides. Protect sensitive areas such as wetlands and stream banks from the impacts of livestock grazing, and minimize pollutant discharge to surface and groundwaters from irrigation practices.